In this video, I want to introduce you to the 3D coordinate system. Finally, we get to go into higher dimensions. First off, let's look at the axis. I write them with z going up, y going to the right, and x coming towards you. One of the problems with doing 3-space is you're trying to draw things that are three-dimensional on a two-dimensional plane. So I have to worry about perspective and that sort of thing, or not. Also, where you put your 3-axis, some people get real picky about it. They prefer the y up in the air where the z is, and the x over to the right, and the z coming towards you. As a mathematician, I'm very abstract. It doesn't really matter which way your axes go, as long as they're labeled, and you keep the labeling in mind when you graph things. The 3 planes we want to talk about are the xy plane, the xz plane, and the yz plane. And they're probably exactly what you think they are. So the xy plane is where z equals 0, the xz plane is where y equals 0, and the yz plane is where x is 0. Let's plot some points. When I plot points, I try to draw a box. So if I have 1, 2, 3, I'll have my axis. For this, I'll go 1 down the x-axis, then I'll go 2 parallel to the y-axis, and I'll go 3 up parallel to the z-axis. The little box helps me see where it is, because otherwise it's just a dot sitting in the flat surface. Let's look at another one. Let's do 1, -1, 1. So here's my graph. I have a little gray box. Notice I go 1 along the x, then -1 to the y, and then 1 to the z. Again, I'll draw a little box to help me see where this point is. The next thing I care about with points is the distance between any 2 points in space. It's just an extension of what you already know in 2-space, except now you have to deal with the 3rd dimension. So here are my 2 points. I've got P1 and P2. I drew a box, and the distance between 2 points is just like you have with 2-space, except you've got 1 extra coordinate. Change in x squared, change in y squared, change in z squared, add those up, take the square root. That is the distance. So now that we have distance, let's try to find the distance between a couple points. Here's my first 2 points. Notice change in x is 2, change in y is 1, and change in z is 1. So my distance is going to be 2 squared plus 1 squared plus 1 squared, giving me the square root of 6. Let me try to plot those points. So the distance between those 2 points we know is the square root of 6. Let's look at -6, 4, 3, and a different point. We're going to look at the point -5, 2, 4. Now the difference in my x coordinate is 1, my change in y is 2, and my change in z is 1. So I have 1 squared plus 2 squared plus 1 squared, square rooted. Again, I'm getting the square root of 6. So now I have 2 sides of a triangle. One is the square root of 6 and the other is square root of 6, but I don't know what the 3rd side is. This could be an equilateral triangle, but it's definitely isosceles. So let's look at that 3rd side. For these 2 points, I have delta x is 1, delta y is 1, delta z is 0. So I have 1 squared plus 1 squared plus 0 squared. We do not have equilateral triangle, but we do have a nice isosceles triangle. Now that we know about distance, I want to talk about spheres. A sphere is just a circle in 3-space. And sphere is hard to say, so we just say S3. So S3 is the set of all points whose distance from a fixed point is constant, just like in a circle in 2-space, just like an interval in 1-space. So I'm looking at a sphere, or S3, centered at ABC with a radius of r. The formula for that is x minus a squared plus y minus b squared plus z minus c squared equals r squared. So just like the circle, but with 1 extra coordinate. All points in R3 that are r distance from ABC. So let's play with a couple. If I have 2 points that are the ends of a diameter called antipodal points. Say I have 3, -2, 1, and -1, 4, 5. The first thing I want to do is find the midpoint because that will give me the center of the circle. To find the midpoint, you take the average of each coordinate. So I have 3 plus -1 over 2, -2 plus 4 over 2, 1 plus 5 over 2. So the center of my sphere will be 1, 1, 3. The radius of my sphere will be half of the distance between these 2 points. Finding the distance, we have delta x is 4, delta y is 6, and delta z is 4. So half the distance would be the square root of 4 squared plus 6 squared plus 4 squared all over 2, which simplifies the square root of 68 over 2. I can probably simplify it further, but since I'm going to square it, it seems kind of moot. r squared is equal to 17. So I have a center, I have a radius, I can plug it into the formula, and I get this. This is a sphere whose radius is the square root of 17, and it's centered at the point 1, 1, 3. So let's try to graph something kind of straightforward. X equals 1. X equals 1 in one space is just the point at 1. X equals 1 in two spaces is a line. When you're in n dimensions and you have one equation, the graph of your equation will be one dimension less. So in one space we have an equation, the graph of x equals 1 is 0 dimension. In 2 dimensions, the graph of x equals 1 is 1 dimension less, which is a line. So in 3 space, the graph of x equals 1 has to be 2-dimensional. And 2-dimensional, linear, is going to be a plane. So the graph of x equals 1 in 3 space gives me a nice pretty plane. Let's look at another graph. Suppose we have x squared plus y squared is less than or equal to 4. When you're trying to figure out what these things look like, remember what you know from 2 space, and then extend it to 3 space. Okay, so I've got this equation, x squared plus y squared is less than or equal to 4. In regular 2 space, that's just a circle with the inside colored in. It's colored in because it's less than or equal to. Now, if I add the z coordinate, there's no restriction on my z, so I have this circle going all the way up to infinity and all the way down to infinity. So what I have is a solid cylinder. I attempted to draw that. It might be easier just to describe it. It's a cylinder of radius, what is the radius 2, that goes centered at 0, 0, 0, 0, and goes up to infinity and down to negative infinity. So we're going to be working on some more of these and graphing these. Just take them one step at a time, figure out what it would be in 2 space, and then try to extend it to 3 space.